that is not the right color. Okay. 4.8. Use the quadratic formula and the discriminant. So just because we need to say it a million times, negative b plus or minus the square root of b squared minus 4ac all over 2a is the quadratic formula. What I usually do is I will allow you to, on a quiz or test, write the quadratic formula, and I'll check it sometimes for extra credit. Sometimes it's actually a question on there. But that way, at a minimum, you're only missing it once and not potentially missing it like 2 or 3 times, depending on the problem. So, we'll just jump into examples. So, if you have a quadratic equation and it's set equal to 0 and you need to solve it, again, on occasion, there might be a situation where you could do it by factoring, or you're like, well, I could complete the square and do this problem or whatever. If it says use the quadratic formula, you have to use the quadratic formula. So, number 4, x squared minus 6x plus 7 equals 0. So, A, B, and C. So we plug it in. So negative b, so that's negative 6 or positive 6, plus or minus the square root of b squared, so that's going to be 6 squared. And I know there's a negative on it, but kind of like what we said yesterday with the completing the square, when you know that it's getting squared, you don't really need to write the negative. But if you're like, well, I want to be completely correct, sure, go ahead. Minus 4 times a is 1 times c is 7 all over 2 times a is 1. So then we have 6 plus or minus the square root of 36 minus 28 over 2. So that's 6 plus or minus the square root of 8 over 2. We want to reduce it down as much as possible. So can I take anything out of my radical?
3 2's. You can take out a 2.
Yeah, I can take out a 2, okay.
Let's talk about that.
So 6 plus or minus 2 root 2 over 2. Now, a common, well, this isn't a great one to demonstrate it with, but it probably looks like we can take out a 2 from, or we can reduce it down. A lot of times what happens is people will say, oh, well, 6 and 2 cancel and that leaves me with 3 and that's it. Okay, but that's not true, okay? Because this is being added up here, added or subtracted, we have to take something out of both pieces to then reduce it. So what I would have to do is take out a 2, and that would leave you with 3 plus or minus the square root of 2 over 2. Then the 2's can cancel and leave you with 3 plus or minus the square root of 2 as your final answer. So the reason I said this isn't a great one to demonstrate with is because a lot of times there won't be something that can come out of both, but people will try to take it out of just one of them. So if it can't come out of both things, it doesn't, you can't do it. And I'm sure there'll be another example where that'll come up in a second, but.
So when we took the 2 out of the radical, is that from just doing the factor tree and everything?
Mm-hmm. Okay. So the 8 would have been 3 2, so 2 times 2 times 2, and we have to take them out in groups of 2.
Okay. Got it.
Let's see, number 6. We have x squared minus 16x plus 7 equals 0. All right, so y'all tell me what to plug in this time.
16 square root of 16 squared minus 4 times 1 times 7 over 2 times 1.
Yeah. And a lot of times I will just write the 2. I won't write the times 1 part because, you know, it's kind of just understood. And if there's ever like a missing term, and then it's a 0. So like if the middle term, say the B term was missing, then it's just a 0 that goes in there. Obviously, if the A term is missing, it doesn't work because it's not quadratic. But if like the B or C term is missing, then you just have to put in a 0 for it. All right, so then 16 plus or minus the square root of, and you would be allowed to use your calculator if you need to be able to like multiply that out. But it's 256. And no, I don't just know that off the top of my head.
I do.
Minus 28 over 2. So that ends up being 16 plus or minus the square root of 228 over 2. Then at this point, you probably need to split 228 because I highly doubt you just know off the top of your head what's going to come out of that.
2 times 114.
2 times 114. And then we can break 114 into 2 times something. 52 times 2 would be
57.
Oh, dang. A little off.
Just a little.
It's okay, you almost had me convinced there for a second.
Yeah. It made sense because the 2 times 2 is 4.
And then can 57 break down into anything
Take
smaller?
out a 3 and 19.
Okay, so then 19 doesn't break down anymore. So I can take out a 2 then, and then I'm left with 57 in the square root. So 16 plus or minus 2 square root of 57 over 2. And so again, this is where we need to take out, and that's why I'm so intentional about saying like we need to take out the 2, so that way you get used to just let me go ahead and factor, or whatever the number is, but in this case it's 2. Factor out the number that's in common so that you remember like I need to factor it out. I can't just take it out of the one in front, because it never seems to matter how many times I say that. Like people will still just cancel the front. I'm like, it's not math. So take out a 2, this leaves you with 8 plus or minus the square root of 57 over 2, which then cancels. So 8 plus or minus the square root of 57. And sometimes people will say, well, can I just cancel the 2 with the 2 and the 2 with the 16? Technically, yes, that's fine. I just like the taking it out method to show that you're like genuinely like recognizing that you need to pull it out, because with bigger problems that are harder, it's not as easy just to cancel it like that. Let's see, let's do one more of these easier ones where it's already like set up for you. Sometimes it won't already be set equal to 0, and so you have to like move the terms over. So we'll do one more of these, and then we'll do one where you have to do that. So number 8, 5p squared minus 10p plus 24 equals 0.
There's a 5 pi squared. I got really scared. You should not be bringing that in here.
Next week.
What?
We're using pi. Yay.
Start trick next week.
We do? Oh my gosh.
We have one section left, and then we start trig.
That's terrifying. Is it all in the same book? Or
Yeah,
did you just-
it's chapter 13 and 14.
Oh.
So, like, basically, we finish this chapter, we jump there, and then whenever we're done, we'll jump back to, like, some other stuff that I think is, like, important.
Yeah.
So, last year I didn't get to jump back to, like, literally anything. I think I did 3 sections after that. But that's because we had so many, like,
Ouch.
delays. Like, I didn't even finish chapter 4 until, like, middle of February. Because we had so many weeks that we were out and stuff.
Okay.
So, but.
I think I got the equation.
And there's not as many notes videos with trig because it's a lot of it's easier just to explain in class. So it's kind of like, we don't really do the flipped classroom, but we kind of do, because I still give you time to do it in class because, like, that's the stuff that's harder. So it's like, you should have the opportunity to ask questions in class. But, so we basically spend more like 2 days on each section instead of just one. But you don't really have notes at home, so. Sometimes you do, like chapter 13 there's some, and then chapter 14 it's more like in-person stuff. So. All right, what am I plugging in here?
10 plus or minus square root of 10 squared minus 4 times 5 times 24 over 2 times 5.
Wouldn't it be negative 10 squared?
Same thing.
Well, yeah, but since it's getting squared, the negative's going to go away.
Oh.
So I just don't write it. A lot of times, you'll actually find me get really, really lazy, and, like, I wouldn't even write 10 squared. I'd just write 100.
Oh.
Which is fine. If you choose to do that, like, completely fine, because you will have the formula. It's like, I'll know that you know what I mean?
You know,
Like,
yeah. How did we get 10 for the first number?
so it's negative b, so b is always the middle term.
Oh, I was thinking it was, okay. That's
What were you thinking?
I was thinking it was negative, and I don't know. I got.
What were you thinking?
But yeah, you'll find when I get really lazy, like especially when I'm like making a test key or something like that, I will literally just start like multiplying this stuff. Like I'll have quadratic formulas down to like 2 lines. I'm like, okay. So 10 plus or minus the square root of 100 minus.
480.
Thanks. I was like, I got the 20 and the 24, and I'm like,
That's not where I go.
over 10. And this is also where sometimes people are like, oh, 10 and 10, cancel, boom. And I'm like, no, can't do it.
Are we going to have I?
We are going to have an I because we're going to have a
Yay.
negative. So 10 plus or minus the square root of negative 380 over 10. So we know an I is going to come out. We're going to see if we can reduce 380 down at all, or like cancel, or yeah, words. You know what I'm talking about. If we can take anything out.
Already know we're
38 and
38 and 10.
That's the only thing I know. That's
I
the
really
only
appreciate
thing
you not starting with 2.
It
Some
was
people are like, they'll just do 2, like with these really big numbers, like all the way down, and I'm like, we could have taken out like a 10, but okay.
Oh,
You
it'll
will
be
always
190.
find me taking out 2s on the biggest numbers because it's the only thing I can remember.
Well, and that's fine, but it's just like funny, like with this one, like when it's very clearly that it can be a 10, and they're like 2. I'm like,
All right.
People like the number 2.
and
2
then
and 19.
yep. So I can take out a 2. So 10 plus or minus 2. Don't forget the I because you got to take out the negative. Square root of.
95.
Thanks.
So
That was
it'd just be 5 times 19.
yeah.
Okay.
So it's whatever. Yeah, whatever just ends up left over.
Yeah.
And then we can take out the 2 from the top. So 2 times 5 plus or minus I root 95 over 10. And so then only the 2 and the 10 reduce, but it still leaves you the 5 on the bottom. So this one's actually the first one where we have 5 plus or minus I root 95 over 5. Now, some people, I would just leave it like that. But some people will ask if they can split it, and they'll end up splitting it to be like 1 plus or minus I over 5 root 95, which is technically fine, but I, again, would just leave it here because it's easier.
It looks a lot happier like that.
That's what I think. It's my personal preference, but you know. Nobody asked me, so. All right, let's do one of the ones where we have to move some stuff around. So I'm going to do number 20. And obviously, if you had a problem where there was nothing left under the radical, like you would need to, if there wasn't an I, like you would need to reduce it down and actually give the 2 separate answers. But we just haven't had one that got rid of the radical completely yet. So 6 minus 2t squared is equal to 9t plus 15. So which way do y'all want to move stuff?
No, move it to the right. We want positives, Jennifer.
All right, we're moving to the right. So
Positives, Jennifer, positives.
So 0 equals 2t squared plus 9t plus 9.
Positives.
So negative b, so negative 9 plus or minus the square root of b squared, so 9 squared, minus 4 times a is 2 times c is 9, all over 2 times a is 2. Is that also the first one we've also had? No, we had an a value in the last one. I was like, is that the first one we've had an a value? So then negative 9 plus or minus the square root of 81 minus 72. Is that 72? 8 times 9, 72. All over 4. So negative 9 plus or minus the square root of 9 over 4. So the square root of 9 obviously is 3, so I'm going to go ahead and split it. So negative 9 plus 3 over 4, or negative 9 minus 3 over 4. So negative 6 over 4, which is negative 3 over 2. So that's one answer. And the other one, negative 12 over 4, which is negative 3. Any questions about those ones? Quadratic formula in general before we do the next thing?
I hate how they look on my paper. I really
How
don't
bad is it? Is it?
Fine.
At least your handwriting is neat. I mean, look at mine.
I can't draw the radicals good. They just end up going like this.
If they go down.
All right, the next thing we're going to do are using this chart that you had, so the value of the discriminant and whatever. So we're looking for if the discriminant, so that's just what's inside the radical, but not the radical itself. Sometimes people get confused with that as well. If it's greater than 0, we have 2 real solutions. Equal to 0 is 1 real solution. Less than 0 is 2 imaginary solutions. So basically, all we're doing with these next problems is we're finding the discriminant and then telling how many solutions it has and what kind. So you will need to kind of know, that in terms of the chart, you'll need to know those. All right, so 32, we have s squared plus 7s plus 11 equals 0. So again, all I care about is the b squared minus 4ac. So 7 squared minus 4 times 1 times 11. So that's 49 minus 44, which is 5. That's greater than 0. So what does that mean? How many solutions do I have?
2.
What kind?
Is it x intercept? Is that it?
No, I asked what kind of solutions they are.
The numbers.
Imaginary. That's the only one I remember.
Real.
Real. 2 real solutions.
Yay.
Let's see. 34. Negative 4 w squared plus w minus 14 equals 0. So b squared, so that's 1 squared, minus 4 times negative 4 times negative 14. So it's 1 minus...
Numbers.
That's exactly what I'm doing.
Great. So that would be negative 223, which is less than 0. So what does that mean?
No real solutions.
Magic.
Yeah, that.
How many?
1, 0.
2.
Oh my god.
2 imaginary solutions.
Yay.
Come on, finish. That was kind of close.
So if it happens to come out equal to 0, then there's just one real, but there's literally only one problem in the section about that. So any questions about those? Okay. There are a section of problems that say solve using any method. Okay, so I'm going to give you like 1 or 2 from that section, and you can just like set it up, get it all like set equal to 0, see if you can factor, because it's probably the easiest method. Then say, well, can I complete the square? Remember, to complete the square, there can't be anything in front of the x squared term, and if not, then you can use the quadratic formula. So problems are 5, 9, 19, 31, 33, 36. Why did I wait? What? Hold on. Pause. 31, 33. Oh, yeah, 36. Okay. And 43. That's the only one I'm going to give you. That's the solve using any method. So
But that one, since we can solve any method with any method, can I just start off with the quadratic?
yeah, that's fine. Yeah, the quadratic, unless it specifies, like you can either choose your favorite one, or if your favorite one's factoring and that doesn't work, then obviously you're gonna have to pick something else. But yeah.